Hey guys, another wonderful edition of Patio Productions where we do review of all things calculus from Mrs. Fox's patio, which is quite soggy today. Just to be honest with you, a little rain. I mean, the clouds are gorgeous right now, but it is a little damp out here. I'm sitting on a beach towel. Can you see this? Literally, I'm sitting on a beach towel, you guys. It's a little wet out here, but no worries. Don't even stress. We're going to be definitely reviewing the topics. So today, for our review stuff, we are going to be talking about Unit 8, okay, as set forth by College Board. And so the stuff in Unit 8 is basically like areas and volumes and some applications of our integrals. And so there's a lot of fun topics in here. It's kind of a little bit squishy. There's a lot of different things. So we're going to do applications of integration today. Hopefully, again, a super short video just to remind yourself. And so one of the very popular things for calculus is to do like the areas and the volumes. So, I mean, we can't guarantee that that's what's going to be one of our free response questions, but like it is definitely like a high probability. Okay. So one of the things that they did in this unit is to ask us to find the average value of a function. If you remember, to do the average value of a function, it was actually kind of simple. You're just going to go ahead and put whatever the closed interval is, a to b. You take the integral from a to b of the function, and the only thing that you have to remember is to put a 1 over b minus a in the front. So just look for sneaky ways that they ask you to figure out the average value of something. And then the formula is actually really pretty easy and straightforward. Yeah, I know, right? Okay, then we did specifically one of the great things that we like to learn in calculus is that relationship between position, velocity, and acceleration. And so we're doing these, now that we know how to integrate, we can now like place them in different spots and like work forwards and backwards. And so just a couple of things to remember here, that the definite integral of the velocity represents the particle's displacement over a unit of time. So I wanted to like highlight that for you guys. So the integral of velocity is displacement, and then the integral of speed is the particle's total distance traveled. Now remember, speed is the absolute value of the velocity. Oh yeah, okay. So there is that's just fun little thing to pull out of there as we're working with our different relationships. And then just in general, guys, so if you integrate a rate of change of something, so if you're integrating a rate, what that guy gives you is the net change of that quantity over the interval. So a lot of times we would say, like, if you integrate the rate, what was that example that we had in our notes? Like you integrate the rate that potatoes were consumed, then you get the number of potatoes, right? If you and so if you're kind of like trying to remember this like in a different setting, you can always just think about, right, like this one that we did up here in this first one. Where is my little mouse? I hate when I lose him. Okay. When we did this one up here, right? When you integrate the velocity, which is like, let's say miles per hour or feet per second or something like that, you're getting the total distance, you're getting the displacement, said that backwards. Okay. And displacement would be measured in like feet or miles. So again, if you're integrating the rate, then you're going to go ahead and get yourself the actual number of that quantity. Okay. Then they spent significant time talking about areas. And so if you just wanted the area between two curves, you're basically just taking the top curve right here, the one that's on top, and then minus the bottom curve over your interval. It's just the integral of that, not a problem. I think it's very helpful to sketch a graph first. No joke, guys. Okay. So just be sketching pictures and you're just going to find that is very, very helpful. And it's not really a punishment. It's just to figure it out. So just top curve minus bottom curve. Another thing is that maybe the graphs are not really meant for us to do the top minus the bottom with respect to X. So sometimes it's better to do it with respect to Y. And so remember, we just sort of like shifted our thinking, like kind of turned the graph sideways. And then remember, for our limits of integration, right? Now that we're doing it with respect to Y, you really got to think about what is, quote, like on top and what's on the bottom. So if we had two curves, right? Like, I don't know, I'm just making things up, like like a this and a this, right? So like this guy, when you actually change your focus, this is the one that's on top. And then this guy right here is the one on the bottom. And then your limits of integration are going to go from like the lowest Y value and then traveling up to the highest Y value. So something of that nature. I know it's a funny little picture, but you know, it works. It works. Okay. Maybe your curves intersect each other at more than one point. I can remember doing things on quizzes and tests and maybe even the homework where it was kind of like they gave you a picture like this and then it went like here and here and here, right? And so basically what you had to do is you had to like partition it up and think about all the different places that it switches from like which curve is on top to which one's on the bottom. So they wanted to highlight that maybe you just sum up a couple of different integrals, or maybe you just take the absolute value of the difference between the two functions, and then it won't matter which one's on top or on the bottom. I would probably just do, personally, I would just divide it up. That makes me less nervous, just doing a couple of different things, okay? So then there's a whole nother section here. So we did a lot with areas now, and now we got to talk about volumes, right? So this unit 8 actually does kind of match up with our chapter 8. And so we next we went to volumes. And for volumes, when they do a cross section that it's built up on top, right, you always want to sketch a picture. You want to draw like a typical cross section, like maybe they're giving you examples of a square or a rectangle or a triangle or a semicircle. So those are the formulas that you want to like be aware of. You find a formula for that area, you figure out your limits of integration, and then you go ahead and integrate all of those areas to figure out your total volume. Okay. This was basically like our project that we did. Remember, we were in class, we could stare at the beautiful pictures, but you know, we're not in class. Should have brought some to hang from my patio umbrella. Wouldn't that have been funny? That'd have been great. You can put them back there on the tree or something, maybe from the garage. Won't get in the way when we play basketball. It'll be totally fine, you guys. Don't even stress. Okay, what other kinds are there? Well, we do volume when we revolve things. So I'm going to actually cover like all 4 of these at the same. It's talking about the disk method and the washer method. You'll notice something. There's no shell method. What? Shell method is not covered on the AP exam. You really just need to know disks and washers. Now, can you use shells? Yes, you totally can, but it's not a necessity, okay? So just as a reminder, if you're going to do the disk method, okay, the disk method is basically just a bunch of circles, right? And so it's basically pi r squared. And then what is your r? Your r is basically your function, okay? So whatever the function is, then that is what you will do. It's just your function. It's actually pretty straightforward, you guys. You don't have to do it with respect to X. You could do it with respect to Y. Maybe if it's going around the Y axis. So this would be like if you're going around the X axis, you want to use DX, right? So this would be the X axis. If you're going to use DY, it's because you're going around the Y axis, okay? But then we have the washer method, and that happens when there's like a gap, maybe when there's 2 separate functions involved. And so basically you're just taking the big R squared minus the little r squared, of course, guys, drawing a picture to help you out. And then this would just be kind of like what we were doing with area, like the outside function minus the inside function. So that's basically what happens here. This right here, your capital R is your outsidest function, and then this would be your insidest function. You can also do it with respect to Y, right? Maybe it's just easier to do it that way. And then the other 2 things that they did is they talked about revolving around other axes. And so this makes things just a little bit more difficult. So that's when the picture really comes into place. So if you revolve your graph around something other than the X or Y axis, you're going to need to account for some sort of space in between. So maybe it's like function minus like a certain number minus a function, or maybe like it's an extra piece. So it's a number plus the function value. It really comes down to what the picture looks like. So please, 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 okay, draw a picture of this. It's going to make your life a whole lot easier. And then the very last thing that they put in this lovely unit is the length of an arc. And so just depending on if you do it as a function of X or you do it as a function of Y, right? It's kind of the same formula. You're just adapting for are you doing it with dx or dy? So no matter what, though, you're going to take the giant square root of 1 plus the derivative of the function squared, and then you'll just either, do that nicely and it'll turn out super cute, or you'll end up using a calculator. So not a problem on that. And that is the topics for Unit 8. Okay, so those are your Unit 8 topics. Again, you are doing all the free response questions. You are keeping up with these things. You're scoring them. You're putting the main ideas, what you knew, what you didn't know, what you need to practice. Remember, this is for you. I am reading them and I am checking them, but I need you guys to just this is so you can pass the AP exam, right? Because we want it to be like this. You know what I'm saying? And you're going to be all pumped and you're just going to be jamming when we get to this AP exam because of all the great prep that we did. Okay. So ladies and gentlemen, let me just get back on and say adieu. Okay. We will see you later. Practice, practice, practice. Turn in those free responses. If it happened to be a little bit late, I still want you to turn them in, guys. This is about you preparing for the exam and doing a really good job. So please, please, please get those babies in, fill out the journal. I think that's it. All right. I hope you guys have a wonderful day. Let's get ourselves some fanfare music to exit out of here, and bye.